Good morning, good evening, good afternoon, wherever you are. Thank you for joining. And today I will talk about building multi-tenant platforms as a service on Microsoft Azure and what I learned from it. So all good things. Okay, first, my name is Tom Kerkhove. I'm an Azure architect at Codit. I'm also an Azure MVP. And if you want to read up on what I do, you can read about it on my blog. So first things first, all good things start with a disclaimer. This is just my findings from my adventures. These are not silver bullets. So please take them as guidance and not as the way to go. And I will mainly focus on Microsoft technology, but basically this applies to all cloud vendors. Okay, and I see there's a first question. I am not able to hear you. I hope you do by now. So if somebody could post another question, then I know. But for now, I will move on and hope you guys hear me. Okay, so there's a couple of areas which I will talk about. The first one is going to be scaling. Scaling sounds nice, but it's not that simple. So I will start with the small basics and then dive a bit deeper. So the simple way to do it is you can scale up and down. So the difference is that you get a bigger box or a smaller box if you scale down. But basically, you have one instance and you add or remove capacity to that one instance. So the benefit is that this is very simple. You just have that one app to manage and you scale it up and down. The problem is that it becomes unavailable when you do the scaling action, typically. And at some point, you will run out of a bigger box or a smaller box. So you're limited to the capacity that the platform provides you. So this is a good approach for basic scenarios, if you ask me, but the true power lies in the scale in and out. So basically what you do is you add more copies of the same application that you have so that it does not have any impact on the uptime of your application. Now, the problem is that this becomes more complex as well because you have multiple instances running. If you're building in an API, then you need to have a load balancer in front, which basically routes the traffic across all of these instances. And you also need to make sure that if it routes one to an instance, that it's still healthy. But Azure, for example, provides services for that. And in the cloud, this is the preferred way of doing application scaling. Now, when you want to determine how you want to scale, also depends on the services that you use. For example, on the left, we have on a function, we have function level applications where you write serverless apps. Which is great because you can focus on the code and they handle all the rest. While on the full right, you have bare metal VMs and VM scale sets, which is fully up to you to configure and manage. So that as the control increases, the complexity increases as well. But that also defines the control over the scaling, let's say. So when you choose the compute infrastructure to run on, you already determine how you will run, package, scale, operate your application. So it always starts from there. It's always good to first take a step back and make sure that you're using the correct compute infrastructure. So let's have a closer look. For example, if you use an Azure function, you deploy an Azure function, and as the workload increases that you need to process, Azure function will automatically scale that for you. There's good, bad, and ugly, as always. So the good thing is they manage all of the scaling for you. And also the bad thing is they manage all the scaling for you because you have no control over how it scales. So I think they're now adding support so that you can put a maximum number of instances. But basically, you just hand them over your credit card, and if you have a scaling loop, it will basically add all the instances that you need. So that can be dangerous for your budget. Getting awareness about this is also not that easy, because if you use auto-scaling, awareness is a key aspect that you must have, which I will come back to. But the awareness basically helps you understand what's going on in your application and determine if it's a legit scaling or not. So there are a couple of horror stories out there. If you just search for Azure functions and horror or whatever, basically this person, I think it was this case where he had a blob trigger and he did something with the job. It's not this one, but another case was blob trigger, did something with the job, saved an update of that blob, which triggered the function again. And basically he had a infinite loop in his Azure function, which basically made it fully scale out. And if you're not aware of this, then you'll notice when you get the bill. Another approach is more with platform as a service. In this case, Azure Cloud Services. But there are other services who work very similar to this, such as Azure Web Apps or app services in general, where basically you have one instance, and in this case, we're processing a queue. So we want to automatically scale that instance based on the amount of messages. Azure Functions did this for us. They have their own scale controller, but in this case, we want to have our own autoscaler who basically uses the autoscaling rules that we define, because we know when it's best to scale based on the performance tests we did, etc. So in this case, the autoscaler just scales when the message count is more than 1, then it will add an instance. If it would drop below 20, for example, it would remove the instance again. So there's a couple of things here again. So the good thing is that we can define how it scales, which is also a bad thing. So depending on what your application needs, that's either a good or a bad thing. Now, with this approach, you get also, and that brings me to this, Azure Monitor Autoscale is one of the hidden gems in Azure, which gives you all of this out of the box. And if you go to my blog, it gives you a run through of how it works. But basically, Azure Monitor Autoscale also gives you awareness. For example, it gives you webhooks for every scale action. It gives you a scale history, and basically fully configure it there in 5 minutes. And it also has an audit log. So that's very nice if you want to determine the scaling actions yourself. You will never configure the perfect scaling rule from day to something that has to grow over time, which is something you need to keep in mind. That's also why I always advise to do this in development already with the reduced amount of instances, because you can cap them, but just to learn how they react. It's easy to have infinite scaling rules because of flapping or because using wrong metrics. So it's also important there to have that awareness and monitor the scaling actions. What is flapping? If you want to learn more, they have good documentation on this. But imagine that we're scaling, auto-scaling app services, and we want to auto-scale when the memory percentage is more than 80%. And we want to scale down when the memory is below 70%. In reality, that will never work because you will be flapping, which means that if you have 3 instances at 70%, which means that it should scale down. If they would do that and remove 1 instance, the average will become higher than 70% again, which will trigger, which they will see as a no operation, because in the end they will be constantly removing and re-adding, removing, re-adding, and that's what they call flapping. So the key there is to have a big gap between the scale up and the scale down criteria. And that's why defining scaling rules is not easy. Then if you have more control again, you can go with cluster platform as a service. In this case, Kubernetes, where we have two applications processing 2 queues each. So there's different aspects already. In Kubernetes, you need a horizontal pod autoscaler, which scales the pods themselves. Well, the deployment actually, but they can only do that on CPU and memory. So in Kubernetes world, you have to use a custom metric provider to get the metrics you need from outside of the cluster. Then you can start auto-scaling when there is enough work. But since we are working with a cluster, we also have to scale that cluster, which will automatically add nodes if the capacity runs out. So we went from application scaling and function and PaaS to cluster platform as a service, where we have to do application and cluster auto-scaling. Does that mean that you have to do all of this? Maybe. It depends on the size of your team, who's using the cluster. Are you the only ones or not? So it depends on the organization, but it could be that you are in charge of this as well. Now there's a benefit. There's a thing called virtual kubelet, which allows you to run pods outside of the cluster. And with the virtual nodes project, you can basically overflow your workloads to Azure container instances if the capacity in the cluster is full. So this is a nice way to basically mitigate capacity issues, keep your application running while the operations team, for example, is checking why the cluster autoscaler didn't run, why there's sudden spike, etc. So it's a bit of a best case scenario for mitigating these issues, which gives us three flavors of scaling basically. So application, cluster, and then outside of cluster scaling or overflow, let's say. I don't see any questions yet, but if you have any, don't hesitate to ask them. I'm more than happy to answer them. So the good, bad, and ugly again for cluster platform as a service. So the good thing is we can now share resources from the cluster across all the teams. And with the virtual nodes, it basically gives a serverless feeling to auto-scaling our applications. Because if we don't have cluster autoscaler or cluster autoscaling in general, we basically just run them outside of the cluster. Should you always do that? I think it depends. I think the best case scenario is a mix of having cluster autoscaler and virtual nodes, but it basically helps you not being blocked by the cluster itself. So the bad thing is you are in charge of everything. So application scaling, cluster auto-scaling, and managing the whole cluster. And with great power comes great responsibilities. So you have to know all of these stuff, how to do that. And scaling can be complex. Okay. The ugly part is that we've seen that for new people, it takes a lot of effort to ramp up on how to scale things and also use things like Kubernetes. But for bigger organizations, this definitely makes sense because you can basically use one platform, which is cloud agnostic, and just run that wherever you want. So, that was my mistake. So there's a project called Kubernetes Event-Driven Autoscaling, which is a CNCF sandbox project, which basically makes application autoscaling on Kubernetes a lot simpler. We bring you the metrics inside the cluster that you need so that you don't need to basically care where it comes from. And we also support running Azure functions in Kubernetes and scaling them as well. Keda is vendor agnostic and has, I think by now, almost 20 different scalers. And it also scales your resources to 0, which is very good because that saves your cluster the resources. You can also scale multiple workload types. We support jobs and deployments. In the next version, you can basically scale your own custom workloads as well. For example, Knative will use this to scale their workloads, and Apache Airflow as well. And basically, it allows you to focus on the application scaling and not the details. So if we have a look at this view again, where basically what it does, it is removes the custom metric provider and the horizontal path autoscaler by just giving you a application scaling component. And then basically you deploy a scaled object, which will then scale your application. And when the workload is gone, it will basically reduce the resources, allowing other applications to scale. But as you saw, we also were able to kill a node because there's no more workloads. And when it comes back, then Kata will also start scaling your application again. Now, I won't go deeper on this today. I have another session on this tomorrow, so feel free to join that if you want to see it in action. Now, there's no silver bullet in what service you should use. It's more important to just know what scaling capabilities they have and what you need to be in charge of, and then make the best decisions on them. So every technology has the trade-offs, every one of them. You just have to know them. And what I've seen is that it's best to not over-engineer things, simply because of the reason we'll need to slate it. No. Start simple and only evolve your platform if you have the need, and you will certainly not need hyperscale from day one. So for example, you could start with Azure Functions, which does the scaling for you. But if you want to have more control, you can take those same Azure Functions and run them in a Kubernetes cluster and scale it over there, because then you can reuse the cluster with other teams. For example, you can have more control if you need to, etc. But that allows you to focus on your application and not the scaling complexity of Kubernetes on day one, for example. But every technology has its use case. So awareness, why is this important? You need to get notified when it's scaling to avoid burning money. And a good example was that we were doing auto scaling based on service bus message count. And we were lucky enough to have that awareness because we were using a wrong metric, and it was scaling on all the message size. So also the dead letter points, which were not being processed. That was being processed by a human. But once we met the certain threshold, it was basically constantly scaling up because of the dead letter messages and not because there were new messages to process. So if we didn't have the auto scaling awareness, we were going to pay a big bill. And lucky enough, we limited the amount of instances it could use. But if you don't have those two, then it will just keep on going, and that's very bad. So there's a couple of ways. You can use webhooks or Azure Monitor auto scaling, for example. Azure Functions has a metric nowadays to help you with that. And it allows you to learn from it and tweak it. That's important. You will not define scaling rules and then don't worry about them for a year anymore. That's not the case. Detect auto scaling loops early on, okay, and use the best approach for your needs, like as monitor notifications, visualize them with metrics, and you can also build your own tooling around it if you want. So this was a metric that I found out to get the function execution count to see, what's going on. And in this case, you can clearly see a pattern. But if there would be a spike after a release, then you might think that something went wrong. Okay, some tips. Resource consolidation pattern doesn't play nice with auto scaling because that pattern says move multiple components in the same compute unit, which means that you will have to scale them in the same way as well. The reason why this is not really good is that every component has their own scaling needs, so it's best to split them out. Now, from a cost-saving perspective, that might make sense. Just think about it and make the best decision for your platform. Always configure a maximum instance count, like I mentioned, and provide reasonable metrics of your remaining work, allowing you to auto-scale on your own metrics as well. Definitely look at Azure Monitor Autoscale, because that's a very nice service in Azure, and always use budget alerts to get notified. And the second big topic you see a lot on this kind of project is tenancy. And multi-tenancy is all about choices. And it's more than just the data and how you will shard it. It's also deployments, operations, pricing, etc., etc. This will be different for every single project based on the needs of the business, but I will try to give you some tips on things to consider. And the first thing is how you will deploy your application. There's a variety of flavors, but what I've seen is that these are the main three ones, which is on the left, the simplest, but probably also the most expensive one, where every tenant gets a fully dedicated deployment, allowing you to also deploy to dedicated tenants and by using deployment rings, meaning I can deploy to tenant A, which is a canary tenant. Once all our canary tenants are still happy, we roll out to the early adopters, and we basically create groups of rolling out their application. Then the second one is a bit simpler. So the application itself is shared. So you have a shared core, but the data itself is sharded across multiple smaller databases. So I'll talk about that in a minute. But basically, you spread it out so that it's easier to scale. But that does not mean you can't guarantee data isolation anymore, because for some customers, that's important for security reasons. And then the one on the right is it's a bit of a mix where you don't have just one instance of your application. You have multiple stamps, which are agnostic from the tenants, but they allow you to scale more. And then you have the sharded database layer, basically. And with this approach, it's also easier. Well, you're more forced in that approach if you have multiple geographies as well. So we'll need to most probably shard our data unless we're doing fully isolated deployments. But that basically means that instead of having one big database, we will create a lot of smaller ones, and we will distribute all the data across them. The reason is that basically you're spreading the load on multiple databases, and you can scale them separately if you want to. The only thing that you'll need to do is define a sharding strategy, a pattern, sorry, which I will not go into. There's nice documentation on that. But based on the shard key, which is a unique identifier, and the pattern that you use, it will automatically assign a shard to you. And then you know where to run your query, basically. It's very hard to choose these patterns. You will most definitely learn from them, but it's really essential, and you might get it wrong, which is fair. And like I said, you have to learn, and also applications change over time, so you might have to repartition things, etc. But it's not easy if you have to change it later. So how does it work? This work? For example, in this case, we have 8 tenants. We get an order in, and then we use a logical shard manager, which basically says, hey, this message is for shard key Cello. In this case, Cello is the name of the tenant as well. So that's the shard key. and then we will look up the connection string in Azure Key Vault, and then we know which shard to connect to. This is a approach. This is not the approach, but we've seen that this is a very pragmatic approach if you're sharding on a per tenant level. If it's based on the data itself, then you will use a different strategy, and then also a different approach for determining what shard you should connect to. But this is very lightweight and simple to do. So the shard managers basically give you a catalog of all the shards in the platform, and they determine the shard that you should connect to for that strategy with that key. Basically, they have the whole metadata of what all the shards are and how to connect to them. Most of the times, they are storing secrets, so I would strongly advise to do that in Azure Key Vault. In the example I did, it's very easy to do that with just a convention and the secret name. You can also use the Azure SQL Database Elastic tools. I think they support Azure Key Vault today. I'm not sure, but in the past they stored all the connection strings in the database, which was why we wrote our own. But that tool also gives you functionality like adding shards, removing shards, rebalancing shards, etc. So they have a more robust suite of things. So I definitely recommend checking that. Now, if we have more of these smaller databases, we also need to be cost efficient because we don't want to pay for we don't want to pay individually for all of these databases. Certainly, as you see here, they are not all consumed as they should, because that heavily depends on the traffic you have and the balancing of the shards. So in this case, for example, we pay 200 euros for 160 DTUs, while we only use 20% of them. So one thing you could do is use elastic pools, which basically is a pool of smaller databases, but you provision the capacity on the pool level. Okay, so that means that the pool will have 100 DTUs shared across 8 of them, and they can demand more resources. So in this case, what we see is that they all have the DTUs assigned that they need. And then we have the 7th shard asking for more, so he gets 93. And then the 4th one needs more resources, but the pool ran out because it only had 200. So that one cannot scale anymore. It runs out of resources. So what you should do in that case is apply resource limitations on a per shard level. And by doing that, basically the 7th one will say, hey, I need more resources, but the pool will say, you've had enough. We keep the rest for other shards, so that the 4th one needs more, then we can still deliver that. And the reason why this should be in place is that if you have a very busy shard or tenant based on the approach, then it should not bring down the whole pool. So as you can already hear, it's finding a balance between paying for every individual database or grouping them together. And I always advise to start with one pool and then make decisions based on that. Because another approach that you can do is, if you have that one noisy tenant, you can split them in multiple resource pools. So that 7 is limited to pool C, and all of the other ones are happy. You could optionally also assign different resources per pool. But another great thing to have is that if you're building a SaaS-based model, you can reflect your billing on top of this. Now, this only works well with sharding per tenant, but let's say that we have a premium customer, they will go to the premium pool and they will also get more resources. So the resource limitations in that pool will be a lot higher than the standard one. So as you can see, the premium ones can get to 250, while the basic tier, which might be a free tier, or a starter tier is capped to 50. So we're basically throttling them on the performance because they pay less, which I think makes sense. So resource pools are a great way to move all of your shards into one pool, but you should definitely configure a maximum per database and or use multiple pools to reduce the impact by others. It also acts a bit as a single point of failure, meaning if the resources on the whole pool run out, then all of the other databases cannot scale up. But that's also why you should monitor them very well. Because instead of having to monitor 100 databases, you just have to monitor a couple of pools or maybe just one pool, which makes it simpler to mitigate. You can just put aggressive alerts on them, meaning if the pool is at 80% of the capacity, we already scale it out, for example. But you should still monitor that resource pool. Now, in terms of determining the tenant that's calling, that's very important to know. Again, this is mainly for tenant-based sharding, but also for your telemetry, it's always good to know which tenant was calling. So if I would do a post to our API gateway, for example, you could basically map the API key to the user and add that user to a group, which is the name of the tenant, and then you add that as an API, a custom header to your physical API. And then the API can use that information to connect to the correct database. Now, this only works well if you have good last mile security. So if you don't have mutual TLS and maybe even a VNet between these two things, then this is a security risk. But you should just keep that in mind. Now, if you're using API management, for example, it's very easy to do this. You can use a policy similar to this to just get the group information for that user and then just send it forward. Is this the best approach? No, but it is a approach, which is very pragmatic. Then, no questions, so I will proceed. I will talk a bit about monitoring. So monitoring, for a lot of customers, this still is the default way to do it. The devs complete the application. When we go live, we throw it over the wall, and it's like saying goodbye to our baby because we'll never see it again, because now it's up to the ops side to operate it. And then you have this situation. They think everything is fine, but they don't have the deep expertise to know what the platform should do. So yeah. And that brings me to monitoring is really a shared responsibility. Ideally, it's the same team running it. If it's not, then you have to make the devs also responsible for telemetry. You can only have good telemetry if you've been on the other side of the fence as well, meaning if the developers are responsible for running the whole thing themselves, for example, in development, then they know how to provide telemetry. So you should train them to use their own stuff. For example, if you run automated tests on a live infrastructure, meaning everything's deployed in Azure, and you run your tests against it, there's an issue, then they should never attach a debugger to the resources. They should fully rely on their own telemetry. And I really hope they already have some. If they have some and it's not enough, they should improve the telemetry first before fixing the bugs, so that they know if it happens again, that basically they know how to investigate. And that's why telemetry is super important. You should correlate all your telemetry for a simple operation in the whole flow. You should also provide application-specific information to all your telemetry, meaning that, for example, if in a multi-tenant scenario, always use the tenant name in the contextual information so that you know who is it about. If you're creating orders, for example, add order IDs, etc., etc. So all the things that make sense to you and that you could use to diagnose, always include that. If you're using correlation IDs, I always advise to send them back to the consumer by using custom headers, for example. The reason is that if there's a support case, then they already have the correlation IDs and they can hand them over to the service desk to improve the analysis. You should never track personal information. Sounds stupid, but still happens. And using different layers of correlation is a great thing. So I will show that in a second. But it's also important that correlation means a lot of things, a lot of different things depending on who you talk to. So you should clearly document the terminology that you use in your platform and what the different correlation IDs are for and what they are representing. So let's use a scenario. So we are listing all the orders from the database, and then based on that, we create an order which is processed asynchronously and stored in the database. So there's already one level of correlation that I recommend, which is just one individual operation. So getting the products and creating the orders. And it's important to see that these are end-to-end. So it doesn't stop in the API. No, it goes over the queue to the order processor, and that should be using the same operation ID. Then there's a second level, which is the transaction or the session ID, which basically groups multiple operations for a single user together. And this ID could be specified by the user or not. The reason why I sometimes open this up is that if you have different components that talk to each other, it could be interesting to have this flexibility. And then there is a third level of the correlation IDs, which is if we process a message from the queue and it tries to store it in the database, but that fails, that message goes back and we will try to reprocess it. So then that time it succeeds. So that's what I call a cycle ID or a processing cycle ID, meaning if we want to troubleshoot the initial failure, we do not want to see the telemetry from the successful processing cycle. If you don't have a processing cycle, sorry, you have to fully rely on the operation ID for the whole order creation. But in case of troubleshooting this issue, for example, that's a lot of noise, and you just want to scope it on the first message processing, and that's what the cycle ID is for. So we have 3 levels. This always depends on platforms, but I've seen that this is a good balance to have. Does that mean you always will use the cycle ID or operation ID? No, but if you have to, then you can do that. It's good to telemetry can feel like drinking from a fire hose. But if you provide the good controls, then that's not the case because you can really filter. Okay. Health checks. So I don't often see health checks, or at least not enough, but you should really add them because they are that simple and they provide a lot of functionality where they report the status of your application. Like, are we up and running? Are we ready to serve traffic? Is the application healthy? How are we connected to our dependencies? Can we connect to our dependencies, etc.? So this is really good information to surface so that operations team can know what's going on in your platform. Because maybe there's a support case, and based on the health endpoint, they can already see that your API cannot connect to the database because it's getting unauthorized, for example. Another great way to use them is if you're doing automated deployments. You can verify the deployment afterwards by checking the health endpoint to see if it's successfully started up or not. You can use it for the measuring latency across the globe, uptime, cold starts, can be avoided by pinging the health endpoint, etc. Now, there's a couple of things to keep in mind if you do that, which is always apply throttling, because if you hand over a health endpoint to some automated tools, then they can really be very chatty. So it's best to put some boundaries on that and force them to be a good citizen by using throttling. If you have an API gateway like API management, they can do that so that it doesn't even hit your API, which is a great way to do that. But if you're reporting on the dependencies that you have, you really need to have a good connection management, which you should have in general, but this really puts some stress on that. So for example, if you create a connection to the database every time, and you have an operations tool checking every second, then you'll have a lot of issues very soon, which is also a good stress test in some cases. But yeah, this is important to know. And it's up to you to decide how far you want to go with this. And I'll show you in a second. You can start very small, but always returning okay if the API started up. Or in a more advanced scenario, you can basically report more detailed information, which is definitely not a must. .NET Core, for example, makes this a lot easier nowadays with the health checks. And they also provide out of the box, well, there's a NuGet package that provides you out of the box health checks for a variety of systems. The reasons why I'm stressing this so hard is that it will not provide any direct business value. So it will always be lower priority on the roadmap until it's too late and there was an outage that you could have prevented. So this is a very simple example of a health check, basically. Just an API endpoint that always returns okay. If it didn't start up, it will just return a 500 anyway, which is a very good starting point, or maybe this is good enough for your application. But with this, I just want to show you that there shouldn't be a reason to have no health check, basically. It's just as simple as this. Alerts are also important. You should always automatically create them because they are part of your infrastructure as well. I've been on projects where this was not the case. Then you have to manually do that for all environments. And if you have multiple geos for all geos, and that really is a pain because you will forget to create alerts. You will misconfigure your alerts. And that's really not what you want to have. What we also advise is to provide a centralized alert handler and basically use an adapter approach. Because what we've seen is that Azure Monitor alerts had 3 flavors of data contracts over time. So basically, we initially had to maintain 3 similar alerts. But what we did was we basically introduced 3 adapters who mapped it from the specific contract to our internal contract, and then did the business logic in that centralized alert handler. So by now, the classic alerts are gone, so it could be removed, but over time, they will most probably change the alert or the common alert contract at some point, which is fair, but with the adapters, you are less impacted. And Azure Logic Apps is really a great way to do that because it's very lightweight, drag and drop, and you're good to go. You can also use emails or whatever if you do not like this. And there is even a template for this in Logic Apps. And then I think this is the last piece. Basically, writing root cause analysis is typically done in production by the operations team, but it's good to train your teams to do that as soon as possible, because there is a lot of things that you can learn from it, such as, did our alerts detect it? If not, are we missing an alert, or do we have to tweak the configuration? Do we have enough telemetry? Could we analyze it already in the way that we wanted it to have? And the root cause analysis really gives a structured way of analyzing the problems, documenting them, and transferring the knowledge to your customers, but also internally in your team. Because I've seen that depending on who's analyzing things, they use a different approach, which is okay. And then people can learn from each other how to use different approaches, which might be better for a certain issue that they need to troubleshoot. And always define action points and follow up at the end of an RCA, and also actually do them. I've seen a lot of RCAs with action points and follow up that never happened. So really follow up on those as well. And if an issue recurs, then you can just refer back to the previous RCA, and then use the knowledge from there to mitigate the issue soon. It's important to know that there is no such thing as failure. A lot of people see outages as failure. No, it will certainly happen. The most important thing is that you learn from it. Because failure will happen anyhow. Okay, next topic is webhooks, but there was a question about CADA. If there is a public roadmap, but CADA is fully open source. So basically the roadmap is on GitHub with all the issues. We do not have any long-term planning, but we are working on that. So if you have something that's missing, be it a scaler or another feature that you want, feel free to go and open an issue. It's on github.com/CADA-core/CADA. Okay, webhooks. Webhooks are fun if you do them well. So I would never use generated URLs because they will give you issues. For example, in this case, we have a generated URL by our platform provider, and our third party will post to them, but by accident, somebody deletes that instance and it's gone. So the natural reaction is that we will just recreate it, but you will get a new URL, meaning you have to update all the dependencies. So you should really put a good DNS name on these services if you have to, or ideally even route them through an API gateway. Because then you'll see that in a second, but then you basically decouple who will process it from how it gets routed. Another example is security. So webhooks by nature don't really have that much security if they have it at all. So the problem is that if you have a fully secured API, in this case with mutual TLS, you can't really integrate with the webhooks unless you open up the security, which is a very bad thing to do, obviously. And again, that's where an API gateway can help you, because with an API gateway, you can basically separate the third party from your internal system, meaning third party can here call an anonymous endpoint or an endpoint with the API key, which is passed by the query parameter. The gateway can apply policies to avoid that the third party is a malicious party. And if everything is okay, it can then forward that same request to your physical API, which has either a generated URL or a nice DNS record, and then use that mutual TLS to authenticate. So your physical API is still secure. Your gateway is basically acting as a gateway. So it also allows you to decouple. So imagine you have one monolith internally and you split that into multiple APIs. The third party is not impacted by this. You don't have to reconfigure anything. Basically, you just route the traffic differently internally, which is very important that we've seen over time, because when you start building a platform, it will evolve anyhow over time, and you don't want to impact your customers or partners with that. So with a gateway, you can do that internally. And as I mentioned, some API gateways allow you to use API key authentication with query parameters, and for webhooks, this is really useful. It's not the most secure approach, but it's better than anonymous. So as a webhook provider to your customers, I always say that you should think from a consumer perspective to really provide good webhooks. It's easy to provide them from a technical standpoint so that it's easy for you as a platform, but that doesn't really make it usable. So one of the things that is great to have is allowing consumers to provide context during the registration. And an example is that we were subscribing for flights, and that was for a specific flight. So let's say from Brussels to London, because we were ensuring flight delay compensation, so that if that flight was delayed, we were going to determine how long, and then that certain person either got a payout or not. If we were not able to provide context during the registration for the webhook for that flight, we basically had to query all the records in the database to find a matching policy for that flight, and then load that from the database and process it, which is very bad for performance. In this case, the provider allowed us to pass context, which was in our case the order ID, so that when the webhook came in our system, we saw that it was for a flight from Brussels to London, and it was for order ID ABC. So we could do a pinpoint in our database, get information for that order, and then just process it, which makes it super user-friendly for the consumer by just adding that simple change. Having APIs to do all of the registration is also a very good thing. Not every provider supports that, but really this is super crucial. An example we had a bug where we created the registrations wrong for the API webhooks, and luckily they had an API, so we could create a small program to delete all of the bad ones. But if that was not the case, then you basically had to go through them all manually through the portal. As I mentioned, with the correlation in general, always return the IDs, and the same goes with webhooks, so that you can link your telemetry with their telemetry. And always provide an invocation history, so that if something is going wrong, you can troubleshoot that and get some more information on which endpoint was called with which payload. And I see there is another question. So which service would you use for queuing? That's a very good one. I'm sorry to say, but it depends. You could use Azure Functions. If that is too small, then it becomes more complex. In the past, I would say Azure Cloud Services, but I haven't seen much investment in that, so I'm a bit skeptical about its future, so I would not use that. You could use Azure Container Instance and run a container. If that's enough for you, I would go with that. If you need auto-scaling, then ACI is less interesting because they do not have auto-scaling unless you write it yourself. So you could use a web job on an empty web app, which is a bit tricky. Worst case, you have to use AKS. It's a bit of a gap in Azure, if you ask me. But I would definitely start with functions if you can. Okay. So if we have a lot of webhooks Certainly internally, it can become the new spaghetti infrastructure. And it also puts a lot of pressure on you because you have to do a lot of bookkeeping on who to call and how to authenticate, what information they are interested in. There's no central place, and it needs to be robust, meaning if I send the webhook to party A, but if it's down, I have to build my own retry circuit breaker, and I'm also not sure if they own a certain domain. And webhooks should really be more like a I don't care, here's an update approach. So that's where an event router comes in. But basically, the publisher just published to the router. He doesn't care who's interested in. People who want to get a notification basically subscribe. They optionally filter, and then the router does all of the heavy lifting. So they provide a central place. They do the retry. They provide the notifications, and they know who to contact. This is really great from an internal perspective. Certainly, if you're using Azure Event Grid, it's harder to use it with third parties because they enforce validation on the endpoints. Meaning, if you will send it to foo.bar, they will need to return an authentication token to prove that they accept that Event Grid will forward traffic. So if you're starting from scratch with a third party, that's fine. If you want to integrate with existing systems, then that might be harder. One way to work around this is to have something in the middle where instead of calling tenant A directly, you add a logic app which is being called, and that logic app forwards it. It's a bit of a hack, but it works. Question is, should you do it like that? Depends on your platform. So things to keep in mind: webhooks are not durable, and if the dependent service is not there, then they might miss it. So only use it for don't use it for mission critical information. Use a broker instead. If you need at least once delivery, I've seen that it's useful to store audit entries of webhooks that are being pushed, so that in case of a dispute, you can show what was sent. And optionally also include the response from the consumer so you can prove what the interaction was like. Don't only allow global registrations, serve more granular updates as well. And again, the example of the flights, instead of having to subscribe to all the flights in the world, I was able to subscribe to an individual flight. So having that granularity is really powerful. Also here, rate limiting is important because you don't want to go down because of a third party sending way too many webhooks. So also provide that. And also provide good documentation and versioning about your webhook contracts. That's important as well. So to summarize webhooks and events, it's really great to build reactive applications and data ingestion pipelines. I've done it myself. It's really powerful. It allows you to decouple things from each other and just react to the events instead of having to know who's next in the chain and having to call them. And it provides the capability to extend existing workflows as well. So a good example, well, another good example is that NuGet was down in 2018 because of this one. So they had the certificate that expired. We've seen that a lot before. But with events, you can basically fully mitigate this. For example, Azure Key Vault allows you to store certificates. And if it is about to expire, it nowadays emits an event so that you can subscribe to it, automatically rotate the certificate, update Key Vault, and then everything is mitigated. So you basically, there's no reason anymore to go down because of an expired certificate. You can read more about that over there, but this is just an example of the power. Should we use webhooks for everything? No. Just use it where it makes sense. And then the last chapter, sorry for overrunning. I'll speed up a bit. We need to embrace change, meaning that in the past we had very stable releases without a very frequent cadence. So that was good, but it was hard to basically shift the focus because it was a very slow release cadence. So basically they wanted to go really fast, but in the end they were still snailed. So that's where Agile came in, and we decided to ship everything to production multiple times a day, which is the new DevOps way of doing things. But very soon it becomes DevOps because your organization is not ready for this. So what I'm trying to say here is you are not Netflix. Right? DevOps is a culture and requires a mind shift. So you cannot do all of this in one day. Your whole organization needs to align with this approach. There's enough material to read about this, but what I want to give to you here today is that there are some small things that you can do as part of this exercise, which is basically all around automation, meaning all manual actions are terrible. They're evil, get rid of them and automate everything. There might still be a chance that there are aspects which you cannot automate, but really aim to be fully automated. Also, fully automate the release of your software. Include testing, include verifications, deployments, etc. And deployment rings are a great way to do this in a controlled way. Like I mentioned, you can have a small group of customers in a canary, a bigger one in the early adopters, and then the majority in the rest of the users. And these rings can still be automated. You could have the canary deployment, then verify the health of that environment, see how it goes over time, and if everything is okay, then automatically deploy to the next ring. This is also how Microsoft does it internally for Azure DevOps, Windows, etc., etc. Does that mean that you have to use deployment rings from day one? Definitely not. Again, it depends on the amount of customers on your platform, etc. It's certainly possible that you just deploy to all of them at once. But again, it also depends here what your tenant deployment model is. So if you have one shared core, there's no way that you can do deployment rings, for example. Also use infrastructure and build as code, which basically allows you to automate a lot of stuff more as well. So we live in a world of constant change, and the problem is that our underlying infrastructure is constantly moving. So we really need to adapt to that. And the cloud vendors are really competing to provide the next unique service, which means that there's a lot of stuff rising, going away, and it's hard to keep up with all of this stuff. So yeah, I'm not going to ask you to add a comment if you know them, but all of these services are more of the older ones, and they are already all gone. So I will quickly go through the life cycle of the service. So there's always a private preview with the rough version, which is set under NDA. You should never use this for production workloads if you have the chance. It's way too risky. It's way too experimental, but it gives you an idea of what is coming. Then when things are going in public preview, everybody gets excited, starts using it. Again, they're good to experiment, maybe start incorporating things, but it's still too early to ship this to production. Once it's GA, it's mostly covered with the SLA, has supported versions. Then I would say you're good to go to production, but at some point things will also go away, which you can have in 3 flavors: deprecation, silent sunsetting, and reincarnation. So if we have a closer look, the best one is the first one, official deprecation. So a service is officially announced as deprecation, and you need to migrate before it shuts down. This is the best case because then you know that it's basically dead end and you need to start looking at alternatives. The second best approach is reincarnation, where you're already using a service. They decided that it's very nice, but they want to do basically re-platform the whole thing into a new product, a 2.0 version, because they think it can give you more value, but because it was so breaking, they decided to start from scratch. And then the silent deprecation is it's still up and running. It doesn't get any development, but it doesn't mean you should stop using it. If we put some examples next to it, for example, Azure Scheduler is officially deprecated, and I think by now it's even gone. Azure ACS as well, which was a painful one. Functions and Data Factory have reincarnated, so that's a good example. It's still there, but it's a fully new platform. And you could also wonder what the future is about Azure Cloud Services. I have no idea, so I'm not stating anything here. But it didn't get any development in the last year, I think, and it's still running smooth. Should you still use it for new projects? I would not personally do that. Are you still using it today, and should you start panicking? I would say no. Just keep it in the back of your head. If you see a better alternative, maybe move, maybe not. I mean, if it's running fine, just stick with it. If it would ever go away, then you would still have enough time to move away. But it could also be your tooling that goes away. So for example, Azure DevOps had a cloud-based load testing that was also deprecated and removed. So basically, you need to always stay up to date to those things and choose an alternative. You might have the option to go with an older technology, which is still very stable. Or you can go with the latest shiny technology that was just released. And there's no right or wrong here. Just need to always choose the best alternative for your scenarios. So just use the tool that you need and not because you want to use the technology. That's something I see more and more when people say, I want to use this technology without any fair reason, just because it's the latest shiny, for example. The latest shiny is certainly not bad, but it might be still too early to build a full platform that depends on this. It's certainly possible as well. You just have to really evaluate the option, compare it with the other ones, and then make a decision based on that. Just don't jump to conclusions. And you should decide this as one team because everybody will be impacted by this. Instead of using one or buying one, you can also build your own. I would not recommend this unless there is no feasible alternative, but it's still possible. But it should be an exception more than the norm. So there really is no silver bullet here. So the questions you should ask is, what's the learning curve? Is it worthwhile? Does it have a vendor lock-in, and is it operable? Does it have a future? There are more questions to ask, but based on those, you should have a better understanding of the technologies, if they are a good replacement or not, and which one to use. Because maybe you're only seeing at the tip of the iceberg, and there's a lot of functionality or issues underneath the water that you're not aware of yet. So it's definitely possible that you choose an alternative, go ahead with it, see, this is not working out, and then you have to basically change again. This is certainly fine, but you need to be honest as a team and just state that, okay, we made a bad decision, time to move on with another alternative. That's not a problem. But the key here is app portability is becoming more and more essential, meaning that in your stack, you can already basically help people or help yourself be less depending on specific technologies. So for example, if you're writing code, .NET Core runs on Windows and Linux. That's already a first good thing. If you're using containers as a packaging model, it's really already more portable across vendors, across clouds, but also on-prem, edge, whatever. If you're doing telemetry, you can also use open telemetry, which is an open specification. In terms of eventing and webhooks, cloud events is also an open specification, which is well adopted. And for service-to-service communication, if you're using a service mesh, then service mesh interface is really what you should be using, because basically it doesn't tie to one specific technology, but it's more of an open specification, allowing you to interact with it without knowing what the concrete technology is. And then in terms of hosting, there's two things. One is you can use Kubernetes, which allows you to run on any platform, or you can use the open application model, which basically allows you to describe what the application looks like, and then host it on a variety of platforms. What the difference here is with Kubernetes, because that's a common confusion, is that the open application model is just a way to describe how it should run. And then every implementation will run it on their infrastructure how they want to. While with Kubernetes, you have the full lock-in, let's say, on Kubernetes. But if you decide to move away from Kubernetes, the Kubernetes gets deprecated, or you just want to use something else. With Ohm, you're not impacted, while with Kubernetes, you have to change from using Helm, etc., to that platform-specific way of deploying things. So here's a quick overview, but I recommend going to their website. But basically, the application developer just writes the code in the containers, which he adds to the application describing how to run it, well, what it looks like. Then the application operator can define how to manage the traffic, auto-scaling, etc., the configuration. These two things are merged in their open application model application. And then you can deploy that to basically everybody. Well, everybody who's an implementer. And then the infrastructure operator decides where to deploy them. And Alibaba Cloud has been the biggest adopter of this, but there's also Rudder to get it running on Kubernetes. There's also crossplay now. There's more and more vendors looking at this, including AWS is also interested now. So this really takes application decoupling a step further than Kubernetes does. So to summarize, you will learn by doing, and sometimes you regret your choices. The most important thing here is that you just learn from them. Don't point fingers to who made the decision. That's also why I'm a fan of a no-blame culture. Make the decisions all together. It's nobody's fault. Just learn from it and move on. And building a cloud platform is never finished. Your platform will evolve, and so does it need. So your scaling will change, your compute infrastructure will change, how it's composed will change, etc., etc. It's never finished. And you should also be prepared for doing migrations like this. For example, the platform we were building was finished in less than a year, but we already had to migrate away from a couple of services because they were deprecated. Nothing is written in stone, so really dare to change approaches and use a product mindset, not a project mindset. So you cannot define today what the platform will look like in 2 months. You really need to be flexible and be able to adapt. So change is coming and you better be prepared. If you want to stay up to date with the Azure deprecation notices, it's not that easy. So I decided to create a GitHub repo and keep track of everything I see. It's improving on the official Azure side, but I don't think it's there yet. So here you can subscribe with the typical GitHub approach, or just follow it on Twitter. And then the conclusion: technologies have different scaling capabilities and trade-offs. Just know them. Provide user-friendly webhooks and route them through API gateways. Define and roll out a good monitoring strategy. Automate everything, and you should use the you build it, you run it mentality. That was it Does anybody have any questions? I don't see any. Oh, okay. I will give you a couple more minutes to determine if you want to ask questions. Okay, there's one from Mike. So let's publish the question so that everybody can read it. So the question is that he likes the cooperation between service desk and desk team. Yeah. Do you have any adventures in providing automatic proactive information? Huh. It depends with what you mean with proactive information, but I think it starts with obviously having good alerts. That's not really proactive. But another thing that developers can do is one, start building a dashboard from day one and start to add the components that are important for them, which means it will most likely be important for the service desk as well, which will also educate the support desk on the components that there are and what they need to know. The devs should also provide their own custom metrics, giving business insights, but also other things like dependency tracking. If we're calling out dependencies, what is the latency, what's the failure rate, etc. But also really annotating them and using good component names. For example, in application insights, there is the application map, so that if you track dependencies, you can see all the components that are basically calling each other and on what they depend, which basically is living documentation for the service desk to know how it works, but also trying to detect, hey, this failure rate is going up over time, so we might have an issue in the future. I don't know if that really answers your question, so feel free to add more to that, but that's what I would reply. Any other questions? In the meantime, I will add a link data repository here. There you go. Okay, one more minute. Okay. No more questions. Then I would like to thank everybody for joining, and I hope you have a good day. Bye.